Hello, I'm Urania, the Greek muse of astronomy, and I'd like to help you with your revision of the astrophysics option in the A-level physics specification. You may also find the following book useful: The A-level Astrophysics Workbook, by Dr. G.K. Fox, exclusively available in the Kindle store. It also happens to have a picture of me on the front. In this video I will review the diffraction pattern for two stars. From the previous video we know that, when starlight passes through a telescope, the light diffracts and spreads out. In this picture of the Orion Nebula, many stars can be clearly seen to be separate from each other. They are said to be resolved. Their diffraction patterns don't significantly overlap. On the other hand, if two stars appear too close to each other, then their diffraction patterns could spread so that they interfere with each other, making it difficult to distinguish the stars as two individual points. They are said to be unresolved. The minimum angular separation, that two stars can be resolved, is called the Rayleigh criterion. According to the Rayleigh criterion, this occurs when the first minima of the diffraction pattern of one star coincides with the principal maxima of the other star. The Rayleigh criterion is approximately given by the wavelength of the light divided the diameter of the telescope. The smaller the wavelength, the smaller the Rayleigh criterion, and the finer the detail that can be seen. This means the resolution at violet light, around 400 nanometers, is almost half that of red light, at 750 nanometers. The greater the telescope diameter, the smaller the resolution, and the finer the detail that can be seen. This is one reason why large diameter telescopes are constructed. When explaining the Rayleigh criterion, it is usual to show three panels, with the diffraction pattern of two stars interfering with each other. This is a map from memory technique. In the first panel, the stars are sufficiently far apart from each other, that the two diffraction patterns don't overlap. They are said to be resolved. In the second panel, the intensity profiles are such that, the principal maxima of one star, coincides with the first minima of the other star. This is the condition for the Rayleigh criterion, and the stars are said to be just resolved. The image of the two stars appears as a peanut shape. In the third panel, the intensity profiles are such that the principal maxima of each star are closer to each other than in the Rayleigh criterion. The stars are unresolved. Here is an example question. At night, the dark adapted eye has a diameter of 7 millimeters. Given that the eye is the most sensitive at 500 nanometers, estimate the Rayleigh criterion for the eye under these conditions. Here is a model answer. First, we write down the equation we will use. We then substitute in the numbers. Finally, we give the answer, with the appropriate units. In this case, the resolving limit of the eye is about 71 microradians. Thank you for watching.